Hello everyone, in this tutorial we will go through the tutorial using the CFD doc and the tutorial called Breaking of a Dam, which uses InterFOAM. InterFOAM is a solver which uses two-phase algorithm, and it is used for incompressible immiscible fluids using the volume of fluid method. And here we have the geometry of the DamBreak, in which we have a 0.292 in the height water column and in width 0.1461 meter with the imaginary wall. So what will happen as the simulation will run, the imaginary wall will open or the gate will open and the flow will hit the obstacle here and then show the effect of it. Okay. For that purpose, we will run the simulation in OpenFOAM, and for that I will be using OpenFOAM version 2306. So let's have a look. It is a multi-phase tutorial, so because of air and water involvement, and we're using InterFOAM. Let's see, what are we using here? Are we using laminar or are we using turbulence one? Okay. So turbulence modeling laminar. Okay, so let's get started with the laminar DamBreak. Okay, I already have a terminal open here, so we will use the Ron's turbulence model as well after this, but we will start with the laminar as it assumes the fluid motion is smooth and ordered. Okay, so let's see. So in OpenFOAM, it is very simple to run DAM tutorial. We have 3 folders. Each folder have different files. So the folder 1 have your velocity file, alpha water file, which have your boundary conditions for alpha water, PRG boundary condition for your pressure, and then we have velocity one, which have a boundary condition for velocities. You can add different parameters here as well, like pressure, heat transfer, depending on your tutorial. So for laminar DamBreak, we only have 3 files here, and in the constant directory we have gravity minus 9.81. We have transport properties as water and air, and sigma value, and the turbulence properties is laminar. So if you will be using a turbulence model rather than laminar, it will be a turbulence model. And in the system, we have a block mesh, which is the geometry definition of the DamBreak. Control deck, yeah, application is InterFOAM because we're using InterFOAM solver. Start time 0 and time 1. Okay, so it will run between 0 and 1, delta t 0.001, and right interval is 0.05. So which means it will have the steps like 0, 0.05, and then 0.1, 0.15 until 1. Okay, 6666, yeah, and the maximum coded number is 1. It also have decomposed part X, so decomposed part X says it's 4, so it will run parallel on 4 core. We have FV schemes and FV solutions here, and the set field should be, yeah, so in height 0.292, So XYZ, XY 0.292. So our height in Y direction and in X, yeah, X direction 0.146, 1461, yeah. That's fine. All good here. For decompose part, the method is simple. See, there's a lot of things which I'm not gonna explain in this video as there is already been a lot of YouTube videos. So the method simple, you can find on YouTube videos that what is this method, how does it work, again with the FV scheme, Gauss linear upwind, what do we use here, divergence scheme, uh, one layer, there's a lot of resources out there. So let's just focus on running the tutorial. Okay, so there's a different ways we can run the tutorial. The easiest way is to run, first of all, let me activate OpenFOAM 2.3 if I remember. Yeah, to just ./all run, enter. Okay, so you can see whatever in that file, okay, it's running it. So it run the block mesh, set fields, InterFOAM, and then it cloned the DamBreak case, okay, and then it run it again, and then the second time run its decompose par. Okay, so within that file there was two cases, one DamBreak, another one DamBreak file, and I think it will show the difference in meshing. We will have a look later on, we will compare about it. Okay, so I while it's finishing, let's, yeah, this one is already done. So open a new terminal. Okay, sorry. Create OF23. That's done. Okay, what do we want to do here? We want to have a look in ParaView, Paraform. Okay, close. Okay, apply, refresh. Okay, alpha water. So you can look at it at its flat surface. Okay, we can have surface with edges. That's showing the meshing of it. What else is feature edges? Nah, wireframe. Again, you can see it's starting with 0, it's all air, and up to 1 is water, and in between it's an interface. Okay, so let's play about it. Let's take a contour of it. So isosurface, whenever it's telling me, let's say alpha water, it's not going to do anything because it's 5 to 6. Let's try anyway. See, it didn't do anything. So our range is between 0 to 1, where 0 is to be air, 1 is to be water, okay? So let's try with the interface contour. There we go. So let's go 0, okay? So if you can see, it captures the interface. Well, if you refine the mesh, your interface will be more defined, but it's just not well defined mesh. But you can put a contour. Now have a look here to capture the free surfaces. Now what, I try something else as well. So rather than this here, okay. Or okay, let's try now. So here you go. It's just showing you how the surface is working. Okay, we done the contour. What else here to play about? Let's put some glyphs on. Okay. Now before the glyphs, let's play more about it. So rather than 0.5 alpha water, okay. Now I want to check what will happen if I put 1. Apply. Okay. 0. Hmm. Uh, yeah, it's just showing where it's no definitely a water. Let's try 0.8. 0.7. Let's try something below 0. Below 5. So it'd be more in favor of the sort of air interface. Try 3. So now I'm moving more towards air rather than a water. Let's try 2. See? Let's try 1. So this way you can visualize difference, like if you want to see just water into the system, you can be stay near to 1, and if you want to see how much air has been around, you can stay to near to 0, and then if you want to capture the interface, then you can just go ahead and capture the interface by going 0.5. Okay, what else can we do? Let's see if within the contour I can plot some glyphs. Okay, so scale factor. That's right, I'm just randomly trying it. Yeah. Glyph should be velocity. And let's just say the glyphs solid. Okay. 0. Okay. So that's the velocity vectors. Oh, fabulous. What else can I do here? There's a lot of features here you can play about with. Let's try some threshold. Okay, so turn off glyph. Yeah, I think threshold and contour are doing that similar sort of stuff. Or let's try something else. Rather than threshold here, we can create a threshold to the DamBreak. See if something happens. Nope. Okay. That's it with it. There's plenty more to, have a look around, but we will have a look once what we will do, we will compare the both of them, this one and the other mesh side by side. So let's have a look. I'm out of here. Okay. Okay, the other one has finished as well. So ls cd DamBreak fine ls. Okay, why it run to 0.4 only? This one was for 0.0 to 0.1. Let's have a look. System decompose par. Sorry. Ah, it was only asked to run till 0.4. Okay, let's try till 1. Save. Start time 0.4. Or you know what, just leave it like this at a moment. We will have a look what's the difference between them, and then I'll show you how to run parallel in the next video. Okay. Keep 0 times solid. PPRG, yep. Alpha water, yeah, you can see it's more refined, and let's have a look. Yep, it has been refined. Yeah, it's only run till 0.4. Okay, so we can certainly have a look by putting a contour to it. Let's have a look what contour will make effect to it. Okay, not 0.5 watt. Something just happened, it just doesn't show 0 here, so DamBreak. Yeah. Okay, let's open another one beside it and see the difference between them. So split the window. I'm on this window. So if I'm this window, you can see the blue lines on the corner. I'm this window, blue lines. Okay, so I have a fine one here. Now file, open. Okay, let's make a file there to upload. Form.form. Yeah, I have a file now here. Back. Okay, so alpha water. Okay. Oh, that's fine. That's more like it. Okay, so we have put a contour here. We're gonna put a contour. Oh, we do. Gonna put a contour here as well. Contour 0.5 apply. Okay, you come here too. So you can see the difference in the interface by improving the mesh. Surface with edges. Surface with edges, okay. I want to run both videos on the same time. For some amount of time. To add camera link. Yeah. Tools, add camera link. Yeah. Okay. So I'm gonna try it. Oh, okay. You can see certainly a change here. What's that? Well, I'm ignoring it for a minute, but yeah. On 0.25. Well, this is only run till here, 0.4, but this one is more, so let's try 5. Yeah. 6, 7. Yeah, you can see it here. By refining the mesh, you are capturing more of water field, while here is very less. So yeah, so you can refine a mesh and play about it and see what would you like to see. From there you can see a lot of data for yourself. And this is for runs. What we will do, that define everything. Sorry, not runs, laminar flow. Yeah, runs would be the same as well. So what we will do, I have seen another one here, DamBreak, InterFOAM, multi-phase, InterFOAM. Yeah. So what I will do, I will compare the InterFOAM with InterFOAM, and we will see what effect it will have. We will do it with a fine mesh with increased time steps. Okay, we will run until 0 to 2 and see what will happen. See you in the next video. But if you like the videos and you would like to see more, please subscribe to the channel. Thank you.